Have you ever opened the console in a Next.js app only to see a wall of red text shouting about a hydration mismatch? It is one of the most common and frustrating errors for modern web developers. But to fix it, we first need to understand what hydration actually is. Imagine the server as a master architect who builds a complete static house, the HTML. It sends this house to the browser so the user sees something immediately. However, this house is frozen. The doors don't open and the lights don't turn on. That is where React comes in. React arrives at the site with a blueprint, the JavaScript, and tries to attach all the interactive parts to the existing structure. This process of turning static HTML into a live, interactive application is what we call hydration. It's supposed to be seamless, but when the architect and the contractor disagree, everything breaks. To understand why it breaks, we have to look at the contract between the server and the client. When Next.js performs server-side rendering, it executes your components and generates a string of HTML. This HTML represents the initial state of your UI. When the browser receives this, it paints the pixels immediately. Then, React loads on the client. React goes through your components again and builds its own internal tree, called the virtual DOM. Here is the golden rule. The HTML generated on the server must exactly match the HTML that React generates on its first pass in the browser. If the server says a button is blue, but the client thinks it should be red, React gets confused. It expects to find a specific structure, and when it doesn't, it warns you that the trees have diverged. This is the root of almost every hydration error.
So what causes these trees to differ? The most common culprit is non-deterministic data. Think about dates. If you render the current time using new date, the server might render it at 10 a.m., but by the time the JavaScript reaches the user's browser, it's 10:01 a.m. The server sent 10 a.m., but the client generates 10:01. React sees this difference and panics. The same thing happens with math.random. If your server generates a random ID of 42, but the client generates 77, the hydration will fail. This is why you should never use these functions directly in your JSX during the initial render. You are essentially setting a trap for the hydration process by providing values that are guaranteed to change between the two environments.
The second common cause is browser-only APIs. Remember, your code runs on the server first. Node.js does not have a window object, it doesn't have local storage, and it doesn't know the width of your screen. If you have code that says, if window is defined, show the logout button, otherwise show nothing, the server will render nothing. But as soon as the browser starts, window is defined, so the client tries to render the logout button. Boom, hydration mismatch. React expects the first client render to look exactly like what the server sent. If you change the UI based on browser-only information immediately, you're breaking that contract. You have to wait until the component has mounted on the client before you can safely use these browser-specific features.
Sometimes the issue isn't your data, but your HTML structure itself. Browsers are very helpful. If you write invalid HTML, like putting a div inside a p tag or a div inside a table without a div, the browser will fix it for you. It will automatically close the p tag before the div starts. However, React's virtual DOM doesn't do this automatic fixing. React thinks the div is still inside the p. When React goes to hydrate, it sees the browser's fixed DOM tree, which no longer matches React's internal tree. This structural difference causes a hydration failure because the actual DOM nodes are not where React expects them to be. Always ensure your JSX produces valid semantic HTML that doesn't trigger the browser's auto-repair mechanisms. So how do we fix it? The most robust solution is the useEffect hook. Since useEffect only runs on the client after the first render, you can use it to set a mounted state. You keep your UI consistent for the first render by showing the server-safe version, and then once the component has mounted, you trigger a re-render with the client-only data. Another trick is using dynamic imports from Next.js with SSR false. This tells Next.js to skip rendering that component on the server entirely. And if you're absolutely sure that a small mismatch doesn't matter, you can use the suppress hydration warning attribute, but use it sparingly. It's like putting a piece of tape over a check engine light. It hides the warning, but it doesn't fix the underlying mismatch.